Okay, we're back with part 2. I'm sorry I got interrupted, but now we got 2 shorter videos, so maybe this will work out okay. A graph is connected if it is possible to travel from any vertex to any other vertex by moving along the edges, by moving along the edges. Okay. A bridge is an edge that, if removed, makes the graph not connected. So here's an example of this. Say that we have a graph that looks like this. If this edge is removed, then it's not possible to get from any one of these 3 vertices to any of these 3 vertices. But if you remove any single of the other edges, you can still traverse all the vertices. Okay? Here is some more vocabulary. A graph is even, or I take that back. It is an even vertex if there's an even number of edges going into it. So, for example, what you would do is you would draw a circle around a vertex and you would count the edges going into it. So I see 1, 2, 3, 4. That is an even vertex. If you do this, there are 1, 2. That is also an even vertex. Okay, an odd vertex then, it's an odd vertex if there's an odd number of edges. So for example, this vertex has 1, 2, 3 edges going into it. That one's odd. So that one's odd, it's got 3, and that one's even, it's got 4. Okay? The degree of a vertex is the number of edges joining the vertex. So for example, this would be even in degree 2, this would be even in degree 4, even 4, this would be odd degree 3, odd degree 3. Okay? So the next thing that we're going to talk about is traceable. And a traceable means that you can put your pencil on any vertex and that you can travel all the edges just one time without lifting your pencil. Okay? And hopefully you notice that the key thing to look at is what is the even or odd status of the vertices and where do you have to start. Because there is a thing called Euler's Theorem, and it says, oh my goodness, you haven't been able to see any of that. Alright, well, there we go. It's called Euler's Theorem, and it says a graph can be traced if, 1, it's connected, and 2, if there are either no odd vertices or only 2 odd vertices. And if it's this scenario, you must start on one odd and end at the other odd. And if they're all even, it doesn't matter where you start and stop. Okay, so that's the notes. In your book, you will find in section 3.1 some problems, and you should do 1 through 16 and 19 through 26. All right, good luck, and do a good job.